quickly summarize what is adsorption and what is chemistry-option, what is physics-option, etc.
Physics-option dana van der Waals force na help tauba. Adsorption na surface ta thokpa magi manung de absorb tawdaba adu absorption na manung de absorb tawigedaba mai particles na soluble.
The corresponding pressure. Clear? The amount of gas adsorbed on the surface of the adsorbent and the corresponding pressure by keeping the temperature constant. This is called adsorption isotherms, the extent of adsorption. Now let us see at intermediate pressure, at high pressure, okay, we're going to find that this extent of adsorption, let us see at intermediate pressure, and when pressure is neither too low nor too high. If the pressure is too high, we're going to get a point of saturation, and that is not going to help us in determining, okay, the appropriate extent of adsorption. So graphically, if you want to study, we're going to study at intermediate pressure. So we're going to discuss about Freundlich's. So at intermediate pressure, this extent of adsorption, X by M, extent of adsorption, X is the amount of gas adsorbed, okay, on the surface of the adsorbent, which is denoted by capital M. So this extent of adsorption will directly proportional to 1 by N, and this N will lies between 0 to 1. Now, after taking out this constant, a proportional sign, a constant will come. K is a proportionality constant, P 1 by N. Now let us take logarithm, taking natural log on both sides. Let us take log on both sides. We get taking log on both sides. Log X by M log log ta into plus log into plus exponential coefficient 1 by N log P. Now if you observe this graph carefully, this graph takes the form of slope-intercept form. Did you remind yourself regarding the slope-intercept form? Slope-intercept form of an equation is y equals to mx plus c in class 11. So this equation is of the form y is equals to mx plus c. So considering this log x by ms y and this as c plus what is this 1 by n m and log s mx. Now let us plot the graph of this particular equation. Now I'm going to draw the graph of this expression Monotaro. This graph is going to have x by m on the y-axis, and on the x-axis we get pressure. So this is pressure. We have log P is the x-axis. Pressure versus extent of adsorption at constant pressure. Adsorption isotherm. Clear? Now, if you draw this graph, you will find that by extrapolating haidi sangdadoi ni graph se ko. Actually graph is the but by extrapolating we can see the point of intercept. So this distance will be called intercept C. See the C or C is your log K. Log K is the intercept. Clear? And 1 by n is the slope. So if you want to find the slope of this graph, slope will be equals to 1 by n. So this is the graph, okay, for this graph is at intermediate pressure, and this graph is the variation between extent of adsorption versus log P at intermediate pressure, and we also call this graph Freundlich's adsorption isotherm. So copy the adsorption isotherm hierarchy. It is a graph plotting between extent of adsorption. Okay, how much amount of gas is already adsorbed on the surface of the adsorbent versus pressure. Maga chana pressure to plot over sigma graphs adsorption isotherm haina khangnai, but pressure versus extent of adsorption graph A. The only thing is temperature should be kept constant. Temperature is kept constant. Pressure versus extent of adsorption graph on pange. It takes the equation y equals to mx plus c log x by m equals to log k 1 by n log p. Nangna what is adsorption isotherm hierarchy? It is the curve plotted between amount of gas absorbed on the surface of adsorbent and the corresponding pressure by keeping the temperature constant. At intermediate pressure, x directly proportional to P1 by n, and you have this x by m equals to k into P1 by n. Take logarithm on both sides, you're going to get a slope intercept form. And then we can come to the next topic. I mutalagi screen so logo the blow ko. Mutangi is topic lage. Symbol in rental once erase the guitar the muk sketch niko. Okay, moving on to the next point. We're going to talk about application. Some application of adsorption. Application of adsorption. Metallurgy. Sulfur containing ores, you are using for flotation process, which is an application of adsorption. And the adsorption of a gas for the adsorption of a gas on a solid gives a straight line with a slope equals to option A log K, option B log K minus na, option C small n, option D 1 by n. So multiple choice question na hunger. So try to do this question as home assignment. Answer higher no ko. May home assignment question number 1 kasi. Then next point is topic types of colloids. What is a colloid? So write down the topic colloid. Colloid is a substance. It is not a substance. Okay. It is not a substance, but it is a state of a substance. Okay, magi phase akoina particle size se kya de kya ko range to ge hai kanda, it is very small. Particle size will range from, keep this point in your mind, it will range from 1 nanometer to 1000 nanometer. 1 nanometer to pick up. For example, 0.2 nanometer. It is not a colloid, it is a solution. Greater than 1000, we're going to call this as suspension. Yung tayo ko, lekom gumba. Okay, lekom, ishing, mud in water, these are all suspension. Heterogeneous dispersion. So before coming to this topic, let me give you the explanation again regarding colloids. First, write down. Let us give some technical definition for pyramid. True solution have been a kaino toxic. Then suspension have been a kaino condoxy. And the ahum subada lactusina sol natraga colloidal solution have been a kaino. So true solution haragadi kaino, it is a homogeneous solution. Okay, homogeneous haitagadi uniformity malani. It is a homogeneous solution which contains small solid particles. Particles may be molecules, may be ions, may be icon. So small particles lani, it is a homogeneous solution which contains small solid particles. So solid particles may be molecules, may be ions, may be icon. So for example, true solution may be sodium chloride in water. You'll get a transparent color. This is an example of true solution. Then another example is suspension. Suspension it is a heterogeneous system. Uniformity malaria. It is a heterogeneous system. Suspension it is a heterogeneous mixture which contains large insoluble particles. Clear? So can you give some example? You can say mud or dirt in water. And another point, colloidal solution it is a heterogeneous system which contains dispersed phase and dispersion medium. Particle will be intermediate size. So you can write down, it is a heterogeneous mixture in which contains dispersed phase and dispersion medium. So you can write it dispersed phase and dispersion medium. Particles are intermediate size. So you can also call this colloidal solution sometimes sol. So true solution net, suspension net, colloidal solution. See the high type 6 in colloidal solution example third you higher PBI like for example of colloidal solution may be aerosol. So what is aerosol? perfumes. Okay, these are aerosol. Gas in liquid or solid. Then you can also say alloys or VI. So many types of examples are there. Alloys, these are solid salts, liquid salts, alcohol salts, aqua salts. So keep this point in your mind: true solution, suspension, colloidal solution. So true solution already, this should be a homogeneous solution which the particles have small size. Okay, it should be less than 1 nanometer. See the now? In case of suspension, it should be greater than 1000 nanometer, and this should be between 1 to 1000 nanometer. So higher point homesick may present distinguished on honor solution the unit number 2 the term record. Project colloidal solution. Okay, particles should have size between 1 to 1000 nanometer. Suspension it is a mixture which contains large insoluble impurities. For example, dirt in water, muddy water. This is an example of suspension. Clear recording point classification of solids toxic, classification of colloids toxic based on the different basis on their appearance and based on their interaction or affinity. So masi kay talk lagi summarize to quickly.
So colloids the true solution suspension then colloidal solution laire duga colloidal the my particle size say 1 nanometer to 1000 nanometer oigedaba duga suspension dana my particle size say one more greater than 1000 or any do true solution dana my transparent solution oini aduga example na sodium chloride and my size na less than 1 nanometer.
Affinity. Then we can come to Michel shock, cleansing action of shock, then condensation methods, preparation of colloids, then Brownian movement are discussed. So important points which you have to recall, keep in your mind: catalysis, enzyme catalysis, and activation energy is 3 topic which is removed from your syllabus.